This is lesson 5-6, okay? I'm recording because I didn't make last periods like perfect, and I know this one's going to be perfect. Okay, so almost like last time, more I's and more simplifying really is what we've got. So last semester I messed up on this, and because I messed up on this, most of my students lost, like, I don't know, certain number of points on their test because I didn't stress this. I'm going to be sure I stress it with you guys. So guys, up above this, I want you to write A plus BI, okay? That is the typical way to write your answer or an expression that has an imaginary in it. So you put the constant at the front and you put the imaginary at the back. So if you look at this right here, x equals I is a solution. Up above that, everybody write x equals 0 plus I, okay? 0 plus I and I are exactly the same thing. The 0 plus I is just in that form A plus BI. So imaginary solutions, you guys, they come in pairs. So if you have 0 plus I, you also have the conjugate, which is 0 minus I, like that, okay? And then 0 minus I is just the same thing as negative I. So what that's saying is if you have a solution of I, you're also going to have a negative I, okay? Here's another one. If you have 3 plus I, you're also going to have 3 minus I, okay? Here's where I messed up last semester, okay? Add this little example right here, and I want you to write negative 2I plus 4. Okay, maybe stick an x equals in front of it. So if negative 2I plus 4 is a solution, then what's the other solution, right? Don't write this down. So my students all did negative 2I minus 4, which is the conjugate, and that is actually wrong. So when you find the conjugate, it has to be in the form of A plus BI, which that is not. So the first thing I'm going to do is reorder it. So it's 4 minus 2I. Then I'm going to do the conjugate of that, which is exactly the same, but the middle sign is different. So the answer is actually 4 plus 2I. Okay, so it's the sign of the I that changes. Look at this right here for 2 seconds. See how the I is a positive and then it's a negative? And then see here how the I is a positive and then it's a negative. I have to do the same thing here. Here the I is a negative and there it's a positive. Okay, who says I understand? Raise your hand, let me see. Great. Okay, so question 1 is kind of important. If you have a solution or a 0 or a root of x equals 6, then someone tell me what is the factor that goes along with that solution. If I have x equals 6, yes, thank you, then I know I'm going to have x minus 6 as a factor. Parentheses, no parentheses, it doesn't matter. They might switch the question the other way, okay? So here's like a part B. They might say that you have a factor of 2x minus 3, and then they want you to give you the root or the 0 or the solution or the x-intercept. It's all the same. So that would be x equals, somebody tell me what that would be. 3 over 2. Yep, set that equal to 0. Okay, so this is the factor, this is the solution, this is the factor, that's the solution. Okay, okay, find a polynomial with the given zeros. Okay, and don't simplify. Question A then says simplify. Let's just get rid of that. We won't simplify. Okay, so guys, look, you have a solution of 3. So everybody write y equals. I feel like maybe you don't understand this, so make sure you answer me, okay? If you have a solution of 3, then you have a factor of, everybody tell me. See, you don't know. You're not answering. Half of you are not answering, so that makes me go, okay, we got a problem. Say it again. If we have a 3, then we have a factor of, tell me, x minus 3. Okay, do you see how I think you don't understand? I'm not toying with you. I'm not trying to manipulate you. I feel like you don't know because you're not answering. Okay, so x minus 3. Now, the thing is, this is a multiplicity 2, which means it's a solution twice. So if it's a solution twice, I'm just going to square it like that. Okay, see that negative I? X, everybody write x equals negative I. Okay. Well, then what happens is the negative I comes over to the other side and becomes a positive I. So then you have a factor of x plus I. Okay? You guys, x equals negative I also is the same thing as 0 minus I. Remember that imaginaries come in pairs. So if we have a 0 minus I, then we're also going to have a 0 plus I, right? The conjugate. So that just means x equals I. Pull your I over to the other side, and the last factor is x minus I. And that's it. Okay? Who says gotcha? Let me see how you're feeling. Okay, great. This one right here has degree of 3. Okay? So everybody go y equals. Let's do the easy one first. See how you have a solution of x equals 3? Everybody tell me that means I have a factor of, talk to me, x plus 3. Good. The next one's confusing. Look, everybody write x equals 2 plus I. Well, remember, imaginaries come in pairs. So if you have 2 plus I, you're also going to have 2 minus I. Make sure you're writing all this down, okay? Now, to come up with the factor, you just take these two things on the right-hand side, the 2 and the I, and you pull them to the other side. So then this guy is going to give me x minus 2 minus I. This one right here, pull those to the left, and you're going to have x minus 2 plus I, and that's your answer. That's it. Okay, who says I'm good? Give me some feedback. Okay, great. Okay, question 3a. If a polynomial equation with real coefficients has a 0 at 4 minus I, then it has another 0 at, go ahead and tell me everybody, 4 plus I. Very good. Here's the one that messed my students up. Look at 3b. Polynomial equation with real coefficients has negative 2 minus I, or pardon me, 2 minus I. Everybody write 2I plus 1. Sorry, I said it wrong again. 2I minus 1, conjugate 2I plus 1. Write that down, and then I want you to cross it out. So when you go through your workbook, then you're like, oh yeah, remember we talked about that fact that's not the answer. Why is that not the answer? Somebody tell me. Let's put it in the right order, right? So the correct order is negative 1 plus 2I for the solution we've got. Therefore, the other solution is negative 1 minus 2I. That's your answer, and you're done. Okay, who says gotcha? Let's see. Okay, great. Okay, now here we go to question 4. It's going to start looking a lot like last time's lesson. Okay, I feel like some of you aren't truly understanding the difference between rationals and others. Okay, now I want you to listen. There is a very good chance that if this is on your midterm, Weber State is not going to make you differentiate between rationals and others. They're just going to say solve it, and you'll just come up with all the answers. Well, separating those and knowing which is tougher than not separating them. So we're going to keep just separating those between rationals and others. And then that way, if you know how to separate them, you know how to do it without separating them, okay? Let's just make a quick definition. If something's a rational 0, when you set it equal to 0, it will factor, okay? The answer can be written as a fraction. Even if it's a 4 can be written as a fraction, you guys. That would be 4 over 1, right? The time you're going to have other zeros is if you have to do the quadratic formula, or if you have to do a square root. That's when you're going to have other zeros, okay? Now, I'm going to show you a trick. Look right here and watch. I feel like the trick wasn't that not everybody understood, okay? So I want you to watch and listen to this. Okay, look. In front of the x to the third is a 1. In front of the x to the second is a negative 3. So look at 1, look at negative 3. You're comparing that to 4 and negative 12, okay? Which one's bigger, 1 or 4? 4. I want to turn the 4 into a 1. What would I have to take out of 4 to turn it into a 1? A 4. If I take a 4 out of a 12, does it turn it into a 3? Yes. Since that matches up, 1, negative 3, 1, negative 3, I know that this thing is going to factor. So it's just a nice little trick that tells you, do I have to do my possibles in the synthetic, or can I just go straight to factoring? Okay, who says I understood that little take out the 4 thing? Raise your hand, let me see. Okay, most of us. Okay, so everybody go x to the third minus 3x to the second plus 4x minus 12 equals 0. Okay, now see this x to the third, you guys? It's going to split to an x to the second and an x to the first. There are way too many people that are being sloppy with their work. Sloppy, I'm not talking about penmanship. Sloppy, I'm talking about besides finishing the factoring, that you think that line is complete. It's not complete. What am I missing? Besides finishing the factoring, what am I missing? N equals 0, okay? You can't do that. It's not complete. And Weber State has very high expectations, so you have to make everything complete, okay? Okay, so see this x to the second right here, guys? Whatever goes right there is going to be multiplied by that x to the second. I need a negative 3x to the second, so that would be a negative 3. Whatever goes right there is going to be multiplied by the x. I need a plus 4x, so that would be a plus 4, okay? Now, when you factor that way, listen what I need you to do. I know that everything's going to match up perfectly because I figured it out, but I didn't double check that negative 12. So when I do that little factoring, I always take a quick second. Is a positive 4 times a negative 3 a negative 12? Yes, so it worked out fine, okay? Now, look right here. If I set that equal to 0, I get x equals 3. Everybody write down x equals 3 and highlight it or put a box around it. This x squared plus 4 doesn't factor. So if it doesn't factor, that goes in part B. So everybody go x squared plus 4 equals 0. I have seen people using the quadratic formula to solve that equation. There is nothing wrong with that, but it's like 4 times tougher than it needs to be. Okay, so I would instead, what's another thing you can do, everybody? Right, solve it. How do you solve it? What do? Move your 4, right? So you have x to the second equals negative 4, and then what? Square root it, and you get x equals, talk to me, plus or minus is right, and then what's the square root of a negative 4? 2i. Good, so you've got 2 answers there. And you've got 1 answer there, and I've got a cube, so I'm feeling good. I can't check plus or minus 2i easily. I don't have an I on my calculator, unfortunately, okay? There is a way to check it. I'm not going to show the whole group because it might freak you out. If there's anybody that wants to come up and I can show you pretty easily how to check this, I will, but I'm not going to do it for everybody, okay? Sorry, one more thing I should have said about this at the beginning. Right here, they tell me that I have a 0 of 2i, okay? I never even use that, just so you guys know. If I have a 0 plus 2i, then that means I have a 0 minus 2i. You guys know the zeros aren't necessary. So at the beginning, I knew that I was going to have plus or minus 2i as complex, okay? You still have to go through and you have to show the work, but that's what that kind of does. I never even use it. I just maybe at the end check, yeah, they matched up, I'm good, okay? Who says I understand? Let me see. Give me some feedback. Okay, let's do question 4. Find all the zeros by factoring. They are not going to tell you by factoring. Those words will not come out. It's just going to say solve. Find the zeros, something like that, okay? So everybody go x to the 4th minus 3x to the second minus 28 equals 0. And then we're going to factor it. The factoring is actually pretty easy. So the x to the 4th, guys, just splits to an x squared and x squared. The 28 goes to a 7 and a 4. Signs are different because it's the negative, and it looks like that. Set this equal to 0, so go x squared plus 4 equals 0. You guys, I know in the past I've had you write an or. I think you should put a comma. Okay, I think if you put an or, it would be okay. I think you should put a comma. And then we're going to go x squared minus 7 equals 0. Solve this one. So you have x squared equals negative 4, and then square root it. So I get x equals, what is that, everybody? Plus or minus, thank you. And then what's the square root of negative 4? 2i. Okay, let's do this one over here. This gives me x squared equals 7 when I pull it over. Square root it. Then I'm going to go comma, plus or minus the square root of 7, and I'm done. Okay, the square root of 7 and the negative square root of 7 are checkable. So store them in, plug them into that equation, and you should get a 0. Okay? Okay, I want to go up on a little side note for just a second. I want you to notice this. If you're graphing a rational function, look right here for a second, and the rational function looks like this, and they ask you to find your vertical asymptotes. Some of you are doing this. Vertical asymptotes come from the bottom, x equals negative 3, comma 7. You cannot write vertical asymptotes like that. They are two separate asymptotes. What if this guy was even and you just squished them together like that? So the way you need to write asymptotes, look at your notes how we did it. Don't look now, but later. X equals negative 3, even. X equals 7, odd. Those need to be written as two separate equations, okay? I didn't take points off for that, okay? But I'm not sure that you wouldn't get points taken off on your midterm, so just be careful with that, okay? Okay, here goes question 6. Now it looks just like the last one, okay? Find your possibles. You take the constant, which is a 26. Now listen to this. Do you see how the 26 is a negative? Who cares? The sign we don't care about. It's the number. Okay, so what goes into 26? 1 and 2. 3 does not. 4 does not. 5, 6, I think the next one is 13, and then 26. The leading coefficient is a 1. You guys, I could do this, look, over 1, but that doesn't do me any good. It's not necessary. So I'm going to put parentheses around it like this, put a plus or minus in front of it, and there is my answer to part A, okay, or that possibles, okay. Find the rational. What do I need to start doing? Talk to me. What do we do? Start plugging them in. Yep, here we go. Grab your calculator, and everybody go 1, store, enter. Then go membar, enter, raise it to the third, minus 8, membar, enter, x squared, plus 25, membar, enter, minus 26, enter, and it did not work. I did not get a 0. Now I'm going to do a negative 1. Negative 1, store, enter, up, up, enter, doesn't work. 2, store, enter, up, enter, and it works. Everybody freeze right there. Once you find it, look what I want you to do. I want you to go x equals 2 and grab your highlighter and say, yay, there's my answer. Now there might be more, but if I don't write it down, I think I might forget to actually answer the question. Lots of people do that, okay? Okay, everybody take that 2 and put it on the outside. I have a 3, a 2, a 1, a constant, so I'm good. So I have 1, negative 8, 25, negative 26. Every person in this room, what's going to happen right now if I'm doing this right? I can't hear you guys. No remainder, right? I'm going to get a 0. So the 1 comes down. 1 times 2 is 2. Negative 8 plus 2 is negative 6. Times 2 is negative 12. 25 minus 12 is 13. 13 times 2 is 26. No remainder. I'm feeling really good. Okay. The original exponent was a 3. I did synthetic once, so now I'm down to a squared. So now I have x to the second minus 6x plus 13. You guys, I'm looking for zeros or solutions, so I'm going to set that equal to 0. Does that factor? Talk to me about that. Does x to the second minus 3x plus 13 factor? No. So does it go in part B or does it go in part C? It goes in part C. So we're going to come down here. X to the second minus 6x plus 13 equals 0. You guys, I could complete the square. Okay. Should I complete the square? No. I'm going to just go straight to quadratic, right? So everybody go x equals 6 plus or minus the square root of, freeze right here for a second. Look what someone did on the quiz. Negative 6 squared. And they missed the middle number because they put it in their calculator like that. Because they didn't remember I told them not to, or they weren't listening. Do not write it like that. The calculator is not going to square the negative if you put it in like that. Instead of writing that, erase it, and what should I put right there? Tell me. 36, yeah. Minus 4 times a, which is 1, times c, which is 13, all over 2 times 1, which is a 2. Now I want you to freeze, just literally freeze right here and listen for a second, okay? Is it okay if I grab my calculator and I just put that whole thing in my calculator and out comes the answers? Yes or no? No. Why not? Because I'm going to get a decimal. Someone said it. And why can't I write a decimal? What's the problem with that? They did not ask me for a decimal. Okay, so I cannot do that. Now look what you do. You grab your calculator and you put that in your calculator. Okay, even if you think you can do it in your head, don't do it. Grab your calculator. Go 36 minus 4, parenthesis 1, close it, new parenthesis, 13, close it, enter, and I get negative 16. Okay, so over here, I want you to write x equals 6 plus or minus the square root of a negative 16 all over 2. I want you to freeze again. If you did not take 10-10 last semester, I am especially talking to you. Okay, I'm talking to everyone, but I am especially talking to you. Can I divide 2 into everything and get 3 plus or minus the square root of a negative 8 over 1? Yes or no? No, I cannot. I cannot do that. There's one reason why I can't. Just one. Someone tell me why not. Why can't I do that? What's the problem with that? Well, it's an I. It's because the 16 is in a root. If it was outside of the root and it was everybody, I could totally do that. But it's in. I cannot do that. Tell me what to do right here. I'm not done. What do I do? Evaluate that square root of 16. Exactly right. Square root of negative 16. So everybody write down x equals 6 plus or minus, what do I put? 4i over 2. Now I want you to freeze. Okay? If the 6 was a 7, don't change it. If the 6 was a 7, could I cancel the 2 and the 4 and get 7 plus or minus 2i? Yes or no? No. It's rude. It's rude. If I did that, who would I be rude to? Tell me. The 7. You're excluding the 7. Look. Here's a person. Here's a person. Here's a person. If you're not going to invite everybody to the party, then don't invite anybody, because it's rude to leave out that 7. Okay? Now, it wasn't a 7. It was a 6. Can I reduce? Tell me yes or no. Yes, because everybody can go. So I can do it, because I'm not excluding. So 2 goes into 6 3 times. 2 goes into 2, or 2 goes into 4 2 times. 2 goes into 2 1 time. If you answer like that, that is completely acceptable. You will get full credit. Okay? There's nothing wrong with it. Is the 1 necessary? Why not? But why doesn't the bottom matter? You're dividing by 1. Like if you have 5 divided by 1, it's still 5. And if you have a 1 on the bottom, it's still the same. Somebody said, and you're exactly right. There are your answers. Okay? Okay, question B. This will be the last one we're going to do like this, and we're going to do something different. Okay, find the possibles. See the constant? It's a 4. Don't worry about the sign. What goes into 4? 1 and 2 and 4. The leading coefficient is a 2. What goes into 2? 1 and 2. Some people leave their answer like that. You're not going to get anything for that. Okay? So it's going to be plus or minus with a parenthesis. On the top, 1. On the bottom, 1. 1 over 1 is 1. Change the bottom. 1 over 2. I'm out of changing the bottom. Now I have to change the top. 2 over 1, 2. 2 over 2, 1. Got it. 4 over 1, 4. 4 over 4 is 4 over 2 is a 2. I already got it. There we go. Those are my possibles. If you don't have the parenthesis, you'll probably miss all the points. Okay? Okay, grab your calculator. Let's start checking. Everybody go 1, store, enter. 2, membar, enter, raise it to the 4. Minus membar, enter, raise it to the 3rd. Plus 7, membar, enter, x squared. Minus 4, membar, enter, minus 4, enter, and it worked. The very next thing I'm going to do, guys, is I'm going to write x equals 1, And I'm going to highlight it because then I know that I've written my answer. Now I'm going to do synthetic with a 1. See if I'm missing anything. 4, 3, 2, 1, constant. I'm good. So I go 2, -1, 7, -4, -4. Someone tell me right now, if I'm doing this right, what's going to happen? No remainder, right? 2 comes down. 2 times 1 is 2. 2 minus 1 is 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 8 minus 4 is 4. 4 times 1 is 4. I'm feeling so good. Okay, everybody freeze right here. Look at the numbers that I'm left with. Can I factor this? Will that thing factor, or do I have to keep hunting? Tell me. It factors. Look right here. I'm comparing the 2 and the 1 to the 8 and the 4. The 2 to the 8. The 8's bigger. If I took out a 4, I'd have a 2 and a 1. 2 and a 1 matches with 2 and 1. I can tell it's going to factor. Okay? This is a 4, so this is a third. This one's trickier, so watch. 2x to the third plus x to the second plus 8x plus 4 equals 0. Look why this is trickier. I need a 2x to the second, or x to the third. So the x to the third is definitely going to go to an x and an x to the second. One of those has to have a 2 in front of it, but I don't know which one is going to have the 2, so I have to wait for a second. Okay, look. Whatever goes here is supposed to be multiplied by the x squared. I need a 1x squared. I can't put a 2 here because the only way I could get a 1 is with a fraction. I don't want to do that. So the 2 doesn't go in front of the x to second, it's got to go in front of the x. So if I want a plus 1x second to the second, that's going to be a plus 1. If I want to get an 8x, whatever goes there gets multiplied by the 2x, that's going to be a plus, I want a plus 8, so that's going to be a plus 4, because 4 times 2 is 8. Okay? And then I'm going to check and make sure that a positive 1 times a positive 4 is a positive 4, and it is. When I multiply them together, it works out. Okay? Look. See this 2x plus 1? Set it equal to 0, and you get x equals, the 1 comes over and becomes a negative, divide by 2. Come back up to the top, put it with the other one that you found, and now you found a second one. Okay? This x squared plus 4 doesn't factor. If it doesn't factor, where do I put it, everybody? In the others, right? At the end. So everybody go, x to the second plus 4 equals 0. Pull my 4 over. X squared equals -4. Square root it. X equals, what is this? Plus or minus, keep talking to me, 2i. So I've got 2 answers there, 2 answers there. I've got a 4th, and I'm feeling good. Can I check those? Not without some work. If you want me to show you, I will. I could check those very easily by plugging them back in. Okay? Okay, who says I understand this? Let me see. Raise your hand, big high, let me see. Okay. Now, I want to talk about this. Okay? It's not super easy. It showed up on one midterm about 2.5 years ago. Do I think this is going to be on your midterm? No. I really thought about not doing it. But what if I don't do it and then it ends up popping up again, right? I want to have a clear conscience, you guys, because this is important to me too, that you do well. So I'm going to show you how to do this. As I do it, I want you to stay calm, and I want you to keep reminding yourself it's probably not going to be on my midterm, okay? Okay, here we go with question 7. Given this equation, find the possible numbers of positive, negatives, and complex solutions. Okay, here we go. See how this exponent is a 3. Everybody write down 3 solutions. I know I'm going to have 3 solutions. Okay, now just watch this closely, okay? Positive. Everybody write down the word positive. To find the number of positive solutions, here's what you do. you count the number of sign changes. So look, I'm at a positive and it changes to a negative. So there's a sign change. I'm at a negative and it changes to a positive. So that's a sign change. I'm at a positive and it changes to a negative, and I'm at a sign change, and I've got a sign change. So I have 3 sign changes, okay? Everybody put 3 right there, okay? Now, don't overthink this. Just do what I'm telling you, okay? If we have imaginaries, which are part of the complex, they're going to come in pairs. So now I take that 3 and I subtract 2. So I'm either going to have 3 or 1 positive solutions, okay? If I subtract 2 again, then I'm going to have a negative 1. I could never have negative 1 positive solutions. That doesn't make sense. So once I get into the negative, stop subtracting 2, okay? Okay, let's go to negative solutions. I'm going to show you the long way, and then I'm going to show you a shortcut, okay? So to find the number of negative solutions, wherever you see an x, you're going to put in a negative x. So everybody go plug negative x in for x, okay? So look at the original problem. Everywhere I see an x, you put in a negative x, okay? So in parentheses, negative x to the third, minus 2, in parentheses, negative x to the second, plus 4, in parentheses, negative x, minus 1, okay? Good luck. Awesome. See you, buddy. Okay, now let's simplify this. Look, a negative to the third is a negative x to the third. A negative to the second is a positive, but it's multiplied by that negative right there. So it's actually going to be a negative, and that's a 2x squared. If you're not paying attention, you're going to be very confused. A positive 4 times a negative x is a negative 4x, and then you have a minus 1. So all I did is put negative x in for all the x's. Now I count the sign changes again. So from a negative to a negative, no sign change. Negative to negative, no sign change. Negative to negative, no sign change. So I had no sign changes. So I know I'm not going to have any negative answers. Subtracting 2 doesn't make sense because now I'm in the negatives, and negatives doesn't make sense, okay? And complex can mean something that has a square root, like in that part C we kept doing, something that has an imaginary. Those are complex, okay? So here are your options, okay? Here's option A. You have to pair the 3 with the 0, and then the 1 with the 0, okay? So I'm going to go 3 positive. I know I'm going to have 0 negative. You guys, if I'm supposed to have 3 solutions, I've already got my 3 solutions. They're all positive. So how many complex would I have? 0. So that would be 0 complex. The other option is this. Besides 3 positive, you could also have 1 positive. So I want everybody to go 1 positive. I know I don't have any negatives, so I'm going to go 0 negatives. But I have to have 3 solutions, and right now I only have 2. So the remaining solutions must be complex. So I have 2 complex, and those are my 2 possible scenarios. Okay? Who says I understood that? Raise your hand, let me see. Okay. I want to show you a shortcut to the negatives. Look right here. Everybody look up. This is a big shortcut. Save you tons of time. See this x to the third? Do you see how it's odd? Here it was a positive. Here it's a negative. See how this is an even? Here it's a negative. There it's a negative. See how it's an odd and a positive? Now it's a negative. The 1 just stayed a 1. So here's what you do. Anything that has a negative exponent, here and here, when you're finding the number of negative solutions, you change that sign. So that would be a negative x to the third. That's not odd, so it stays. This guy's odd, so it changes. -1, and that's what you do. So all this right here isn't even necessary. I can just skip it, okay? And I will skip it on the next one. Okay, here we go with question 8. The biggest exponent is a 6. So I know I'm going to have 6 solutions altogether. Some positive, some negative, some complex. Okay? To find out the possible number of positive solutions, leave it just the way it is and count the sign changes. Positive to positive, no change. Positive to negative, 1 change. Negative to positive, 1 change. I had 2 sign changes. So I could have 2 positives or 0 positives, because 2 subtract 2 is 0. Just always subtract 2. That's what you do, okay? To find the number of negative, look what you do. Find the exponents that are negative. That would be this guy and this guy. Change those signs. So now your equation would be, or your equation would be 4x to the 6th plus 5x to the 4th. That guy has a negative exponent, so I'm going to go plus 5x to the 3rd. That guy has, that has an odd exponent, so I change the sign. The next guy has an odd exponent, so I change the sign. Now I'm counting sign changes. Positive, positive, none. Positive to positive, none. Positive to negative, 1. So 1 negative. When I subtract 2 from 1, I'm in the negative, so it doesn't make sense. Okay? Here are your possibilities. Look. Okay? Pair the 2 up with the 1, pair the 0 up with the 1, and then fill the rest in with complex. So look, guys, I could have 2 positive. I know I'm going to have 1 negative. Altogether, I have to have 6 solutions. Well, so far I only have 3, so that means that I must have 3 complex. Let's do the next scenario. The next scenario is 0 positives. I know I'm going to have 1 negative. Then how many complex would I have, everybody? 5, because I have to have 6 solutions. That's it. Okay? Just about a 0% chance of being there, just so you know. Okay? Okay, that